Assalamualaikum warahmatullahi wabarakatuh and Dr. Sah. My name is Nurul Binti Rashid, Matric ID P22EC0053, and this is my video presentation for assignment 4, converting audio to image for subject SECV3223, Multimedia Data Processing, Section 2. So for this assignment, I was tasked to design an approach in converting audio data values into spatial data values and display them. So I need to enhance the initial algorithm that is given for this assignment. There are multiple possible solutions to implement, which are map based on point-to-point, map based on frame-to-frame, map based on features such as frequency, energy, ZCR, location XY, intensity, or map into certain fixed images based on certain attributes, or maybe a combination of those solutions. Dataset audio I used for this assignment are link.wave, ring02.wave, Windows Matric ID. So the initial algorithm for this assignment is very simple. You just take the audio and then get the corresponding image of RC times RC using square root, and then it finds the minimum and maximum value of the audio before it maps the value and normalize the range from 0 to 255 and reshape the value into the image. So the output of the initial algorithm is in grayscale. And there are issues with it because it only uses point-to-point direct mapping that does not have any attributes, so it is hard for us to differentiate between the signals. And then it lacks frame-based analysis, which means that it doesn't account for temporal changes in the audio signal, which could be important for many applications. For example, if you want to analyze the output. And then the output is in grayscale, so it is hard to differentiate between the intensity level. So next, the proposed algorithm, solution map 1. So for this algorithm, it's actually just an improvised version of the initial algorithm by changing from point to point to frame and intensity. So the function takes audio signal A, convert it to the frame to frame spatial representation with color intensity. The function set the default value for color map type and frame length if they are not provided. Then it calculates the number of frames in the audio signal, reshaping the data into frames of specific length. The intensity of each frame is computed using the root mean square RMS method, and these intensities are normalized of range 0 to 255. The normalized intensities are then mapped to colors using the specified color map, which I choose the pink color map, and then the color are reshaped into RC times 3, which RC is the square root of the number of frames, and the contrast adjustment is applied to the resulting image to make it more visible. And next is the call function, which is only I try to map the figure into one figure by using subplot. So like every signal, all three audio will be processed and will be displayed in the same place. So this is the comparison between the initial algorithm and the proposed algorithm. As we can see, sample map 1 it is in grayscale and there's no attribute. Meanwhile, in the solution map 1, it's used intensity and also frame to frame solution. So we can see here, since I use color map pink, the white color actually represents the highest intensity, while black represents the lowest intensity, and the pink is actually the hue in the middle. So we can see here, for example, the ding.wave sound start off with a high intensity. That is why the left side of the map is actually white. And then for the Windows battery critical wave, it start off with low intensity, then goes to high intensity. That's why there's we can see there's changes from the black frame to the white frame, and finally end with the black again. So we can see it is much easier to see the differences between the intensity. So in conclusion, this assignment taught me how to convert the audio files into image by converting audio data values into spatial data values and display them. I learned that there are different approaches to map the signals, and I chose to do combination of frame-to-frame mapping and pictures mapping by intensity. So this assignment is truly interesting and insightful as I discovered that by doing a proper mapping for a certain circumstances, extraction data could be much more efficient. So that is all from me. Thank you for watching.